So just as integration by substitution came from the chain rule, we're going to take the product rule and get a new integration technique from it. So let's start by writing down the power rule. Sorry, the product rule. So we'll take the second times the derivative of the first plus the first times the derivative of the second. And what I'd like to do here is change the order a bit. So let's take the f of x g prime of x on the right, and we'll subtract the other part to the other side. So on the other side, we'll have the derivative of f times g minus the other half of the product rule, g of x f prime of x. Now, what I can do is, just like I did for substitution, is I'll throw an integral on both sides. In fact, I'll write it across everything. And I can also note that, well, hey, I've got the integral of a derivative. So those are going to cancel away with each other, basically. So this gives me my integration by parts formula, f of x, g prime of x. If I want to integrate that, I can anti-differentiate the g prime to get g. But by doing so, I need to subtract away the integral. I'm going to take the derivative of f. Actually, let's write first. I'm going to take the antiderivative of the g prime to become g, and then take the derivative of the f dx. And this is called integration by parts, because you're going to integrate part of it and leave the other the same. But then we also have another part of the problem left to do. So let's see, what else can I do here? Well, let's make a shorter version of this formula. So what I can do is I can identify two parts of the integral I want to learn more about, and I'll let u equal the f, and I'll let dv equal the rest, g prime of x dx. Now, what else can I do here? Well, I can take that u and find a du by just taking the derivative. Likewise, I can take the dv and figure out a v by finding an antiderivative. I don't need to have a plus c here. I just need to know one of the antiderivatives. That'll be enough to solve the problem. So notice that here in the rest of the formula, I have a g of x, a g of x, and an f prime of x dx. But I also have the f of x here. So I can make all those substitutions and get a shorter version of the integration by parts formula. My f of x becomes a u. My g prime of x dx becomes a dv. I've got f times g, that's u times v, minus the integral. I've got a g of x is v, an f prime of x dx, that's a du. And so that's the shorter version of integration by parts that you'll often see people use as well. So let's do an example where I apply this formula. This problem, I want to find the integral of 2x cosine of x with respect to the variable x. So in order to do this, I'm going to need to identify my u and identify my dv. So I see two things being multiplied together. Well, three things, the 2 and x and a cosine, but let's just combine the 2 and the x and the cosine and the x. In fact, you'll see here in just a moment why I will combine that with the dx. And the reason why is I want to let u equal, and I have to choose between 2x and cosine, and I want to pick the thing that gets simpler, or at least not any worse, when I take its derivative. And 2x, if I were to take its derivative, would yield 2 times dx. And that looks simpler. Instead of just a 2x, I've got 2 times dx, or just really just a 2 involved there. So that's good. And then what's the rest of my integral? Well, my dv should be the rest of the integral. And that's my cosine of x dx. And I can integrate that, just a plain old cosine by itself, that's not hard. Sine has a derivative of cosine, and that'll be my v. So now I can take this integral and rewrite it as u times v again, that's u times v minus the integral, and here I'll put v du, which from my chart, my v is sine of x, my du is 2dx. Now it looks like it's gotten more complicated. Now I have 2x sine of x, but I've also got this minus sine of x times 2. But if you've done it correctly, if you've made the correct changes, notice that my 2x became simpler. It became just a 2. My cosine became a sine, and that's not much worse than cosine. So I'll just rewrite things a little bit. I got this nice 2x sine of x minus, and I can just write this as 2 times sine of x dx. And I can integrate that just normally. I can just use the constant multiple rule to get 2x sine of x, stays the same, minus, oh, don't need the integral sign since I'm actually taking the integral now. Bring down the 2, and sine integrates to get negative cosine of x. Notice that I throw extra parentheses around there to be safe because this minus should involve the entire antiderivative. And then since I'm done taking the integrals, I'll add my plus c now. And all that is left for me to do is simplify. It gets me a 2x sine of x. I got minus a minus, so that's plus 2 times cosine of x plus c. And there's my final answer. Now, since it's my first time doing integration by parts, I should probably check and make sure I did it correctly. So this is the optional step you can take at the end of an integration problem to make sure that it worked out. So I'm going to take the derivative with respect to x of 2x sine of x plus 2 cosine of x plus c. And of course, the c is going to go away. The derivative of a constant by itself is 0. So what's left for the rest of this? Now, because I did integration by parts, to check it, I'll have to use the opposite of integration by parts, the product rule. And so I've got my first and second function here. So I'll take the second times the derivative of the first plus the first times the derivative of the second. All right. Plus, I still have that 2 cosine to take care of. Well, that'll just become negative 2 sine of x. And let's just note that, hey, I've got 2 sine of x canceling with negative 2 sine of x. So my simplified final answer is a 2x cosine of x. And heck, I go way back up here, 2x cosine of x is exactly what I was asked to find the antiderivatives of. So that checks out as my answer.